Example 515 shows us how we might change the order of integration in an iterated integral. So we're presented with an integral that is set up as a type 1. We can tell it's type 1 because we're integrating with respect to y first, and we can see that the y bounds involve functions of x. So for starters, let's go ahead and define our region as the type 1 region. So our lower bound for y and our upper bound for y. Lower bound is the y equals 0 equation. Upper bound is the 2 minus x squared equation. And then x is between two constants. X is between 0 and root 2. So looking at our region this way, we're able to create the equations that define our boundaries. And we can draw a picture as well of our functions. So the region goes between x equals 0 and x equals root 2. So that's in the positive x axis. And then the y bounds are from 0 and 2 minus x squared. Well, 2 minus x squared is an upside down facing parabola. So we know the region that we're looking at is in the first quadrant underneath that curve. And originally it was given to us as a type 1 region, but we want to redefine it as a type 2 so that we can change the order of integration, thus integrating x first instead of y. So we would like to switch from vertical strips to horizontal strips. And that would mean that we need to define the left and right side of our region using functions, but not functions of x, functions of y. So this is our type 1 setup. We're going to change it to type 2 by redefining our functions. Instead of being functions of x, we want to solve them and write them as functions of y. We know y will be between constants. This time x will be the variable that's defined between functions. The left function is actually x equals 0, so that one's pretty easy. The right function, it is this y equals 2x squared, but we need to define it for a value of x. So we need to solve that for x. So that would become y minus 2 equals negative x squared, or 2 minus y equals x squared. Square root both sides. And technically there is a plus and minus in this square root, but because our region is in quadrant 1, I know I'm only keeping the positive version of this equation. So the upper bound for our x values will be the square root of 2 minus y. And then the y values, they are going to be the smallest value of y for our region is 0. The largest value of y, that's going to be where this parabola intersects the y-axis. So we can look at that equation, y equals 2 minus x squared, plug in 0 for x, and we would find out that the value for y on the y-axis, that y-intercept, is 2. So the highest value of y is 2, smallest is 0. And now we can set up our integral with the reversed order. So let's go ahead and start that up. The function that we are integrating is not going to change. We're not changing anything there. But the area increment, dy dx, now becomes dx dy. The inside integral has our values for x, which goes from 0 to root 2 minus y. The outside integral has our values for y, which goes from 0 up to 2. So notice we did not simply just swap the integrals with the current bounds that they had. We had to deconstruct the type 1 region and then redefine it as a type 2 region to get the appropriate bounds for that integral.